Today we're going to be calculating speed. Before we calculate speed, review the last video on motion graphs. Here we have our three motion graphs. Let's shrink that down a little bit. We're going to be describing the motion of the object in these three graphs. But before we describe the motion, let's first identify the type of graph it is. This first graph here is a distance versus time graph. This one over here on the left-hand side. Distance versus time graph, and that type of graph represents the speed of an object. So this is a speed graph. Our second graph here in the middle is a position versus time graph, and a position versus time graph describes the velocity of an object. And then our last graph here, our speed versus time graph, this graph represents acceleration. Now that we've identified our graphs, let's describe the motion in each of these graphs, starting with our speed graph, the one on the left. First of all, right here along this part of the line, our object is moving relatively slowly at a slow constant speed. The line is straight, but the slope is sort of shallow, so it's moving at a slow constant speed. And then right here along this portion of the line, the slope increases. So the object begins to move at a faster constant speed. And then right here, the object stops moving and is at rest. Notice in our speed graph, the distance continues to move up. It never moves in a negative or downward direction. Our second graph is a position versus time graph, or a velocity graph. Here in this first section, the line is very steep, so we know the object is moving very fast. But not only does this line describe the speed of the object, but it also describes the direction. In this case, this is a positive slope, so the object is moving away from the reference point. At this point, the object, during this part of the line, the object, one, started moving a little slower because the slope is a little less steep, it's a little more gradual, and it turned around and started traveling back towards the reference point, negative motion. And then right here, the object stops moving and is at rest. The object did not make it all the way back to the reference point down here. It stopped just short of the reference point. So it walked fast away from the reference point, more slowly back towards the reference point, and then stopped before it got all the way back to where it started from. In our third graph, we have an acceleration graph. So this first section of the line right here is showing that the object is speeding up. It's getting faster. And then right here, this flat part is showing me that the speed is staying the same. So I have a constant speed. And then the object slows down. This negative slope shows me that it's slowing down. And then right here in this last segment, it is a straight line at 0. So we know that the object is not moving. So the object is speeding up, and then it is moving at a constant speed, then it is slowing down, and then it stops. Let's take a look at today's topic, which is speed calculations. In order to calculate speed, how fast something is going, you need two things. You need the distance of the object and the time. So the formula for speed is the distance divided by the time. You're also going to be using the formula for average speed, which is very similar to the speed formula. The only difference is that you take the total distance traveled divided by the total time traveled. Now the units for speed are meters per second, that's a very common speed unit, miles per minute, that's also very common, and kilometers per hour. Now how do we get those units? We'll take a look back up here at our formula. Distance can be measured in several different units. It can be measured in meters or miles or kilometers or inches or feet. There's a lot of different ways to measure distance. And time can also be measured in several different units, like seconds, minutes, hours. Now, depending upon what our distance and time are being measured in, that will determine what our speed is being measured in. For example, if our distance is measured in meters and our time is measured in seconds, then our unit will be meters per second. If our distance is measured in miles and our time is measured in minutes, then our unit would be miles per minute. If our distance is measured in kilometers and our time is measured in hours, then our unit would be kilometers per hour. And the same holds true for our average speed formula, and we'll see that in a minute. So let's take some time and do some practice problems using these two formulas, calculating average speed. Our first example problem: how fast does the wide receiver run if he covers 18 yards in 3 seconds? Well, here's our formula down here. Speed equals distance divided by time. I always like to write the formula down. Oops, sorry about that. I always like to write the formula down. And then I look to the problem to find out what I know. How fast? How fast? Well, that word describes speed. So that's what I'm looking for. I'm looking for how fast. Does the wide receiver run if he covers 18 yards? Well, yards, that's a distance unit. So I know that that's distance in 3 seconds. And seconds is a time unit. So I'm going to label that time. So now I know that I'm looking for speed, and that the problem gives me distance and the problem gives me time. So I'm going to put what I know into my formula. Speed equals 18 yards divided by 3 seconds. Distance of 18, time of 3. And now I just do the math. 18 divided by 3 is 6. Well, 6 what? Because I need to have a unit for my speed. How do you know what the unit is? Well, go back to your problem. Remember that the unit for speed is derived from the unit for distance and the unit for time. And since the distance was measured in yards, my speed is going to be measured in yards per, and whatever we measured time in, and that is seconds. So 6 yards per second is the speed of the wide receiver. We can also use this formula to solve for something other than speed. For example, how far does the quarterback throw the football if it travels 8 meters per second for 3 seconds? Well, I'm going to use the same formula here. Speed equals distance divided by time. I always write that down. And now I go to my problem. How far? Well, how far something is represents its distance. So I'm going to be looking for the distance. How far does the quarterback throw the football if it travels 8 meters per second? Meters per second. That is a speed value for 3 seconds. Seconds is a unit for time, so that's a time value. So now what I'm going to do is plug what I know into the formula. I know that the speed is 8, so 8 equals, and then I don't know what the distance, so I'm going to write a D up there, and I'm going to divide that by the time of 3 seconds. Now, it's a little bit more tricky to solve a problem this way, to solve for distance. I can't just multiply or divide because I first need to get the D by itself. So what I'm going to do to get the D by itself is move the 3 over to this side of the equal sign. And the way I can do that is by performing the opposite math operation. Right now I'm dividing by 3. So if I multiply by 3, that would allow me to cancel those 3 outs, and I'm left with D all by itself. But I have to be fair. What I do to one side of the equal sign, I also have to do to the other side of the equal sign. So now I'm left with D equals 3 times 8. And so I multiply 3 by 8 and I get D equals 24. 24 what? I was looking for distance. So I come back up to my problem and I look at the speed value. The unit for speed was meters per second. Meters is a distance unit, and so that is the unit that I'm going to use for my answer. So I know that the distance the quarterback threw the football was 24 meters. For this example problem, we're going to be using the same formula. That's what I like about these calculations. I don't have to memorize all kinds of formulas. I can just use one formula to solve for 3 different things. The punter kicks the ball 32 yards, that's distance, on a 4th down. How long, that's time, will it take the ball to land if it travels at a speed of 2.5 yards per second? That's the speed. So for this problem, I am looking for the t, and I know the speed and the distance. So I plug in what I know. 2.5 is the speed, equals a distance of 32 divided by the time. Now this problem is the trickiest problem you will be solving this year. And that is solving for a variable that is underneath the dividing line. So let me take you through the steps to solve. The first thing I need to do is move the t over to the left-hand side of the equal sign. To do that, I have to complete the opposite mathematical operation. Right now, on the right-hand side, we're dividing by t. So what I can do is multiply by t. That will allow me to cancel the t's out. The t's aren't on the right-hand side anymore. What I do to one side of the equal side, I have to do to the other side of the equal sign. So I also multiply this side by t. So now I have moved the t over. My equation now looks like this. 2.5 times t equals 32. Now I've got one more step to get t by itself. I need to move the 2.5 to this side of the equal sign. And to do that, all I have to do, the opposite mathematical operation. The opposite of multiplying, because right now I'm multiplying by 2.5, is to divide. Divide by 2.5. That will allow me to cancel it out, and t is now by itself. But don't forget, what you do to one side, you have to do to the other side. So now I have 32 divided by 2.5. So 32 divided by 2.5 is 12.8. 12.8 what? What is our unit here for time? Well, I look back up into my word problem at my speed value. The speed was 2.5 yards per second. The time was measured in seconds, so our answer will also be in seconds since we were solving for time. You will also need to be able to calculate speed not only from word problems but also from motion graphs, from distance versus time graphs specifically. What is the speed of this volleyball player between 2 and 6 seconds? Same formula. Speed equals distance divided by time. The only difference here is we're going to be getting our distance and time from a graph instead of a word problem. So between 2 and 6 seconds, well, here's 2 seconds right here. Here's 6 seconds right here. So we are looking for the distance traveled. At 2 seconds, the distance was 10 meters. At 6 seconds, the distance was about 14 meters. So that's a difference of 4. So the distance is 4 meters. I divide that by the time between 2 seconds and 6 seconds. That's from here to here, that's 2 seconds, and from here to here is another 2 seconds. So our time is 4 seconds. So 4 divided by 4. So my speed equals 1. 1 what? What's the unit? Well, let's go back to our graph, just like we would go back to our word problem. The distance here is measured in meters, and the time is measured in seconds. So my unit for my answer would be in meters per second. And our final speed calculation is using the second formula that we looked at a little while ago, and that was the formula for average speed. Average speed equals the that was pretty messy. The total distance. Let's try this again. Total distance divided by the total time. So I looked at my graph. What is the average speed of this volleyball player? Well, the volleyball player from beginning to end traveled a total distance of 15 meters over a total time of 12 seconds. So I take 15, I divide that by 12. 15 divided by 12 is 1.25. 1.25, don't forget your unit, meters per second. Alright guys, those are examples for speed calculations. I'll answer any questions you might have tomorrow. I'm out.